Yeah, we are back. We are back. We are back. I will continue with our series of responses on the previous item. So we had explored, I think it was graphite, and now what do we have? Next, we have methane. No, we had explored graphite. Next, it has to be methane. Recall that the item was requesting for properties of any one of the substances. So I decided to give properties of all the substances so that I give you a clear dissection of the question. So I gave properties. I started by giving properties of ionic compounds, and the ionic compound of interest in this case was potassium chloride. I gave properties of the giant metallic structure. Therefore, I gave properties of metals. I gave properties of giant covalent structure. Under that, I gave properties of graphite, diamond, and sand. Now we have methane. Methane is also a covalent compound, but for it has a simple molecular structure. A simple molecular structure looks like which one? It looks like this one here. Like water. Water is a covalent compound, but for it is not having this structure of what? Of diamond, graphite, and silicon dioxide. You see, within the structure of diamond, graphite, and silicon dioxide, you have non-metals. You don't have a metal. That's why I'm calling those things covalent compounds. And that type of structure is a giant covalent structure. However, there are also other covalent compounds which do not have this type of structure. And for that case, those compounds are known as liquids or gases. A key example is the structure of water. I think the structure of water, one side you have H2O, and on another hand you have H2O. The water molecules, the H2Os are linked together by weak intermolecular forces of attraction. So you see, this is not a giant covalent structure, but it is also a covalent compound. But the only difference is in the forces of attraction and the nature of the substance which you are dealing with. For liquids and gases, they have simple molecular structure. Colleagues, don't forget that. Liquids and gases have simple molecular structure. Graphite, diamond, and sand are the only ones at this level which have the giant covalent structure. So in this case, methane is a gas. Methane is a gas. Therefore, methane also has a simple molecular structure. We start with the state. What do we use to recall those properties? We use state, solubility, and structure. Those are the key words: state, solubility, and structure, plus M for melting point, C for conduction, and D for density. Alternatively, one can use science solves structures money cannot do. Science for state, solves for solubility, structure for structure, money for melting, cannot for conduction, do density. So then we start with state. Methane is a gas. Why is it existing as a gas? Because of the weak intermolecular forces of attraction. The molecules are very spaced. The molecules are very spaced. So it exists as a gas at room temperature due to presence of weak intermolecular forces of attraction within its molecules. Then solubility. Methane is a covalent compound. Covalent compounds are not soluble in water. So here it is slightly soluble in water. If you say soluble, that is not correct chemistry. Yeah, it is slightly soluble in water, but covalent compounds, for them, they are highly soluble in non-polar solvents. Non-polar solvents, think about alcohols. So slightly soluble in water, but highly soluble in non-polar solvents. Why? Because they are made up of non-polar bonds. The bonds within methane. The same thing for graphite. Those bonds are non-polar. A bond which is non-polar cannot split due to difference in charges of the bonding atoms. Yeah, like methane is made up of carbon and hydrogen. that bond, the line between carbon and hydrogen, is non-polar, like here. If you have methane is C bonded to hydrogen, it is C, sorry for that, it is C H4, CH4, and this is the same as C carrying H and another H. It is carrying 4 hydrogens. It is carrying 4 atoms of hydrogen, like that. And those bonds, they are non-polar. They are non-polar. Why? Now you cannot split methane to form ions. You think about that. Which ions will you form at this level here? Which ions will you form? That's why we say that it is non-polar. Those non-polar bonds, for them, they want, or they bind strongly with non-polar solvents. Then what is the other property? The other property is for structure. So methane has a simple molecular structure. Allow me expand this. It has a simple molecular structure. Simple molecular structure in which molecules are held together by weak intermolecular forces of attraction. Now, like for our water here, are you seeing the weak intermolecular forces of attraction joining the H2Os, the van der Waals forces of attraction? So the same thing occurs here. Has simple molecular structure in which molecules are held together by weak van der Waals forces of attraction. Then it has a low boiling point. Liquids and gases have low boiling points as compared to solids. So methane has a low boiling point. Why? Still due to presence of the weak van der Waals forces of attraction. They require less heat to break. Look at them here. You see, they are evenly dotted. But you come to graphite and look at it, or diamond. You see, the bond is joining atoms are not dotted. If they are not dotted, what does it imply? That for them they are strong. But these ones that are dotted, those ones that are dotted, the ones that exist in liquids and in gases, those ones are weak. Therefore, they require less amount of heat energy to break. Then, after melting and boiling point, conduction. Methane does not conduct electricity. Colleagues, earlier on I said that for anything to conduct electricity, it must be made up of ions or electrons. Methane is a component of natural gas. You cannot, that's what I've been explaining. You cannot split methane to form ions. Methane is not made up of charged particles. Charged particles, I'm referring to ions. Methane is not having electrons. Therefore, it does not conduct electricity due to lack of charged particles and mobile electrons within its structure. Then density, methane has a low density. Why? Due to loose packing. Those molecules are loose, they are spaced. It has a low density due to loose packing of molecules within its structures. So these 6, there are other points, however, those 6 properties can work on any other covalent compound which exists as a gas or liquid, which exists as a gas or liquid, which exists as a gas or liquid. So other points, no, sorry. This was a typing error. Those are the points. There are no others. Others, okay, can be chemical properties. Like one can also say that methane undergoes complete combustion in air to form carbon dioxide and heat energy. When you burn natural gas, the natural gas which we use for cooking in homes, methane, that is a property. Methane undergoes complete combustion in excess air to form carbon dioxide and water vapor. It is a chemical property. So one can also think about those chemical properties. Colleagues, as of now, allow me first stop here and we concentrate on part C. Now I have done part B exhaustively and I have extended it to other compounds. I have extended it to other compounds. Kindly take note of those compounds. Practice with other compounds. You can use like for one of the substance. It was what? The first substance was potassium chloride. Now, instead of having potassium chloride, you think about another ionic compound. Can you formulate those properties and explain them very well? Then for a metal, we are dealing with the aluminium. Interchange, then you put iron. Can you list those properties explicitly? Then for the giant covalent structure, we consider the diamond. We consider the graphite. We are dealing with graphite. We are dealing with graphite. So instead of having graphite, can you swap that graphite with the sand and list the properties exhaustively? Very well explained. For methane, interchange methane, change methane and put ethane, or change methane and replace methane with a liquid. A liquid like which one? Which liquid can I look at? For example, ammonia. Replace it with ammonia. You can interact with a scenario that has ammonia being used in the manufacture of fertilizers, like that. So kindly think about those things. Think out of the box. You get the clear gist of the substance. Allow me stop here